Thank you for joining us for this 30 West IP webcast update. This was recorded March 2021, so the information may have changed if you are viewing this later. During this update, we will bring to your attention the somewhat surprising use and definitely very confusing use of some oceanic waypoints. And we will also take a look at some updates for the North Atlantic. In the course of your job of hauling people and their things all over the planet, you've no doubt had the opportunity to make several oceanic crossings using latitude and longitude waypoints. And in your FMSs, you probably had to use some sort of special shorthand coding in order to represent those points. There's no doubt you're familiar with something like this, for example, representing 50 north, 030 west. You might even be familiar with this. This is an indication of a half-degree waypoint use in the North Atlantic, 5030 north, 030 west. But what about something like this? Have you come across this before? This is a little confusing. This particular waypoint designator is confusing because it is unfamiliar to most of us. This question was recently posted to a Slack channel, and fortunately, there were a couple of folks who did respond, pointing out that this is an ARINC 424 coding format. No doubt you are familiar with ARINC 424 codes. However, like most of us, you're probably accustomed to seeing the letter for the quadrosphere identifier at the end or in the middle of the code, or even the letter H at the beginning of the code, indicating a half-degree waypoint in the North Atlantic. It's very uncommon to us to see this designator at the second position. In this illustration, we recreated the flight plan that crew had received. We want to point out that we believe it's unlikely you would see these codes in your business aviation aircraft. But for our illustration, we wanted to show you these codes as it appeared to that crew so that you can see how confusing this would have been if you weren't expecting these waypoints. However, when you look at the printed flight plan, you'll notice the 13-character format of each of these waypoints. And this is where those codes might make a little more sense to you. We've highlighted in red these two waypoints because these are the ones that look the most unfamiliar to us. You'll notice in the 13-character format that these are actually half-degree latitude waypoints. And this unfamiliar coding is the coding that's used to indicate a half-degree latitude waypoint when the longitude exceeds 100 degrees. This document is the ARINC Specification 424 Manual, and it sets forth the air transport industry's recommended standards for the preparation of airborne navigation databases. Chapter 7 in this document addresses naming conventions for things such as fix identifiers, waypoint names, including unnamed waypoints such as latitude-longitudes that don't define an entry or an exit boundary point. These waypoints are defined as undesignated. That means there is no published 5-letter name or code for those waypoints. So this section sets a standard for coding these latitude and longitude waypoints into a navigation database, including whole degree and half degree latitudes. It's very likely that most of you have enough experience with the whole degree of latitude waypoints that you could look at the ARINC 424 5-digit character format and easily figure out the latitude longitude for those waypoints. But the half degree of latitude waypoints are probably a different story. We can see in the examples provided in the ARINC 424 specification manual, the code used for the quadrosphere identifier is either in the first position or the second position of the 5-digit format, depending on the longitude. So that essentially yields 8 different combinations we would have to memorize to try to understand the ARINC 424 code that we see on the flight plan. This essentially begs the rhetorical question of, how could this possibly be confusing, right? This document was shared by one of the respondents to the original question posed on the Slack channel. There were actually a couple different versions of this document submitted in the responses. Maybe this helps with solving the confusion. But then again, if you have to carry a document with you to help remind you of what the codes mean, then perhaps we should just revisit the codes altogether. Maybe expand them to a 7 or 8 character capacity to alleviate this confusion. If you have attended any of our courses or perused the Resources tab on our 30westip.com website, then you might remember seeing this very similar looking document that we made. We limited the half-degree information on our document to the North Atlantic only because up until recently, we were under the impression that half-degree waypoints were only used in the North Atlantic. You'll also notice that we have indicated the letter H at the beginning for the half-degree waypoint. That's because that is the recommended coding from the NAT Systems Planning Group. Remember, the AirInc Specification 424 sets forth the air transport industry's recommended standards for the preparation of airborne navigation databases. The databases prescribed by this document are also used by computer flight planning systems, flight simulators, and other applications. This document is not a requirements document. Some procedures are not compatible with this database standard and sometimes cannot be coded for inclusion in some of these airborne databases. Likewise, not all waypoints are included in the database either, and even though the code might fit the standard, the undesignated waypoint may not be included in the database. Earlier, we saw a flight plan that was generated using Jeppesen ITPS, and that flight plan provider does use the AirInc 424 coded waypoints. We ran the same flight plan using AirInc Direct. And oddly enough, AirInc Direct doesn't recognize those waypoints using the AirInc 424 standard. You can see in this flight plan sample that we received, they substituted those unknown waypoints or undesignated waypoints using XXX03, XXX04, for example. However, you can see beneath each of the XXX values the actual full 13-character format which defines the waypoint in use. It's interesting to note that when using ForeFlight or JEPFD to plot an oceanic route, and you use the AirInc 424 format coding, such as 40E75, that AirInc 4-character format will get replaced by the full latitude-longitude if it's an undesignated or an unpublished 5-letter named code. This appears to apply to both whole-degree latitude and half-degree latitude undesignated waypoints when you use the 5-character AirInc 424 format. In this example, we see that JEPFD does the same thing with undesignated waypoints when using the AirInc 424 code. Because we were surprised to learn of this use of half-degree latitude waypoints in the Pacific, we contacted Oakland Center to ask them about their use of these half-degree waypoints. They explained to us that they do not use these on a regular basis. They explained they do not issue these in reroute clearances. They do not use these in PAYCOTs. These are the result of an operator filing a flight plan using these half-degree latitudes in the Pacific. They said to us that if the operator files the flight plan and the system sees no problem or no conflicts with these waypoints, then they will issue that as a clearance. But otherwise, as a whole, they don't use half-degree waypoints in the Pacific regularly. They said it's just much easier to use the whole degree latitude, longitude, and it's much less confusing that way. So don't expect to get a random reroute in the Pacific using a half-degree latitude waypoint. It's something that you have to file and request to receive. The North Atlantic, on the other hand, is a very different story. The oceanic managers in that region have fully embraced the use of half-degree of latitude waypoints. Recently, the NAT SPG issued an update to this NAT OPS Bulletin regarding waypoint insertion and verification procedures. In this OPS Bulletin update, they are specifying training items for pilots and dispatchers, as well as items to include in your operations manual where half-degree waypoint identifiers are used. It appears that this revision to this NAT OPS Bulletin is also an indirect way that the NAT SPG decided to update us on the fact that they're expanding the use of half-degree waypoints in the North Atlantic. Prior to this update, I think we were all sharing the understanding that half-degree waypoints in the North Atlantic were limited to the PBCS tracks. We kind of feel like this statement was quietly slipped into this update, advising us that half-degree waypoints can now be included in any oceanic clearance in the North Atlantic, even clearances delivered by voice. Previously, we were told that half-degree waypoints would only be issued via route clearance uplinks, and not through voice. But now, according to this statement, you can expect a half-degree waypoint and an oceanic clearance and a reroute clearance either delivered by voice or by link, and you need to be aware of the procedures associated with using those. Mitch did reach out to a couple of oceanic managers in the NAT region to ask about this expanded use of half-degree waypoints in the NAT. In their replies, they indicated that this is something that's been in place for a while now, that they were always allowed to use half-degree waypoints on any routes and at any altitude in the NAT, even though it seems like new news to most of all of us. The manager from Gander actually went on further to point out to Mitch that flight crews are also allowed to respond unable to any of these clearances that contain half-degree waypoints if they're not comfortable with using them or don't understand them. He did reiterate this point. Make sure you state unable and try to renegotiate a new clearance if you'd like to. So to summarize those brief statements found in the NAT OPS Bulletin update, as well as the information we received from the airspace managers, you can file half-degree waypoints on random routes outside of the organized tracks. You can also mix half-degree waypoints with whole-degree latitude waypoints along your random routes, and the half-degree waypoints may be filed at any flight level on a random route. In this illustration, we're showing you a route, an oceanic route, in the North Atlantic that includes whole-degree and half-degree waypoints. You can see at line key 2 left and line key 4 left, you have a half-degree waypoint mixed in with whole-degree waypoints. For those of you that may have forgotten about using half-degree in the North Atlantic or may not have been exposed to it, we'll quickly cover this information for you using this flight plan sample. Down in the route portion of this flight plan, you can see that we've highlighted the waypoints that are associated with the oceanic leg. We've also highlighted in red 2 waypoints that include half-degree latitudes. You can see the 13-character format easily displays the half-degree information to you, so this reduces the confusion. Again, we've highlighted in red in this illustration for you those half-degree waypoints. You can see the full 13-character format displaying the half-degree information easily. And just above it, you notice the ARINC 424 coding format. In this case, the letter H is in the first position to indicate a half-degree waypoint, for example, 5130 north, 040 west. Fortunately, the NAT SPG had the foresight to understand the confusion of using the basic ARINC 424 code of the letter N in the front. That has generated a lot of errors in the past. So the NAT SPG recommended the use of the letter H instead of the letter N to indicate half-degree waypoints in the North Atlantic region. And what's nice about the North Atlantic region is there aren't any 100-degree longitudes. So the letter H will always be at the front in the first position. There will be no need for it to go to the second position because you're never going to cross 100 degrees in the North Atlantic. Some of you with a keen eye may have noticed that this is a sample flight plan from ARINC Direct, and it does include ARINC 424 waypoint coding information. We showed you a flight plan sample earlier from ARINC Direct in the Pacific region that did not include those. Remember, it used 3 X's and then a numeral, a pair of numerals, so XXX03, for example. Well, the difference is that most all of the North Atlantic half-degree waypoints are considered designated waypoints, and they have been included in the databases used by airborne navigation equipment as well as flight planners. I do want to make it clear that these half-degree waypoints that you see in this illustration with the letter H at the beginning are not technically ARINC 424 standard coded waypoints because the ARINC 424 standard would use the letter N at the beginning for this quadrosphere. The letter H is a recommendation from the NAT SPG in an effort to reduce confusion and errors created by flight crews. So using this letter H indicates that the coders do have an option to change the coding as they see fit, and that the ARINC 424 is a recommended standard and not a requirement. An additional change to the ARINC direct flight plan formats to notice is that the half-degree waypoints in the North Atlantic region now use the letter H in the first position rather than the letter N. Previously, ARINC Direct put an attention statement in their flight plans letting you know that the flight plan contains half-degree waypoints that are abbreviated using ARINC 424 format, the standard format using the letter N. So you would have sometimes a discrepancy between your printed flight plan and what you would see in your navigation database in your aircraft, for example. These include the old ones, the old ARINC Direct flight plans use the letter N, while your database would use the letter H. Now they are congruent. They both use the letter H. If you're a Jeppesen ITPS customer, you know they've been using the NAT SPG recommended letter H to indicate half-degree waypoints in the North Atlantic for a while now. And again, this use of the letter H is congruent with the navigation database as well as your flight planning software maybe you use on your iPad as well as your flight planners. First on our list of topics is the NAT Datalink Mandate. Shortly after the Datalink Mandate was implemented, the traffic in the region was greatly reduced as a result of COVID-19, as you're aware. So there was a temporary accommodation for aircraft that are not Datalink Mandate equipped to operate within the Datalink Mandate region. However, as of 25 February this year and onwards, this temporary accommodation has been rescinded. So the NAT Datalink Mandate has been reinstated, and you are now required to meet the Datalink Mandate requirements to operate in the North Atlantic region. Since it's been a while, we want to remind you where Datalink is required. In this map, we have displayed in the yellow regions the lateral boundaries of the Datalink Mandate area. When within the lateral boundaries, the vertical requirement for Datalink Mandate is from 290 to 410. And keep in mind there are some areas that are not included in the Datalink Mandate region. For example, the airspace north of 80 degrees north, the New York Oceanic East Flight Information Region, as well as in the areas where you can receive ATS surveillance service. And remember, in addition to Datalink requirements, if you wish to participate on the PBCS tracks when they are published, you are also required to have RNP4, RCP240, and RSP180 authorization. Our next topic covers OTS Tracks NIL. A recent post on the NATS blog posed a question regarding disbanding the organized track structure. Even though this article is mostly about an analysis of the environmental impact on using more direct routing rather than the organized track system, this blog seemed to have created quite a stir. It got a lot of people buzzing about this disbanding of the organized tracks. People were under the impression that they were going to just do away with the tracks, and then it was just going to become a free-for-all in the North Atlantic, and traffic was going to be crazy. In fact, this article was brought to our attention because of a lot of emails that we had received regarding this subject. As it turned out, this concept of reducing the organized tracks or not using the tracks all the time, it really did not come out of left field. And the author of this article might have done us a favor and ended the article with a little bit of a warning, perhaps, reminding us to just stay calm and carry on. The North Atlantic Safety Oversight Group has actually done some study into this subject, and they have published this paper presenting information on the utilization of no OTS NAT tracks. The NAT region is actually pursuing the reduction of the OTS footprint, and they are doing it in a controlled and progressive manner. So there is no need to be frantic thinking that this is just an out-of-the-blue concept that has no forethought. This progress towards the reduction of the OTS tracks has followed the successful transition from the ACEPS trial to a full application of ATS-based separation in the NAT. On the days where there are no OTS tracks published, you will still just follow normal NAT flight planning rules, and you'll be expected to operate as you normally do in a non-OTS NAT airspace, as you've operated before on random routes. Airline operators will still be required to submit their preferred routes daily, and NATS and NAV Canada will still be required to do their daily analysis for determining the need for OTS tracks. The OTS Tracks nil procedures will only be implemented when NATS and NAV Canada consider the OTS tracks are not required to manage the traffic for that day. This paper also acknowledges the environmental impact brought forth in the article on the blog. They state that delivering the efficiencies can only be done when operators file their best routes. There is a statement in this paper which I think deserves more press than it has received. There is a long-term plan to actually remove oceanic clearances in the NAT. Sweet! Bring it on! There are a couple of other statements we want to draw your attention to from this paper, and the first one is this. The NAT Safety Oversight Group did seek feedback from airspace users, and they determined there is no need to change the flight crew methods of operation. This includes item 4.4 listed above, weather and technical contingency procedures. This has been a bit of a hot topic for folks in this discussion of OTS nil. Looking at the information in this paper, we can see that the random routes of this OTS nil structure will not quite be so wildly random as we're imagining. There will be some application of joining same direction routes, and when you think about it, ultimately you're trying to seek the most efficient route through the North Atlantic. So if you're going eastbound, you're going to be following the most favorable winds eastbound. And if you're going westbound, you're going to be following the most favorable winds going westbound. So really, you won't be going head-on against each other all the time in the NAT because you're in general going to be following the same flow. And the second final statement that we're going to point out basically reiterates the previous statement, which is current flight dispatch and crew training and procedures supports both random and OTS flight operations. So there really are no changes to your operations when there are no OTS published. You will use the same track messages to determine when there are tracks published or when there are no tracks published. The first instance of OTS Tracks nil that we observed occurred on March 9, and this track message was issued by Shanwick, indicating the time of effectivity or the period of effectivity and OTS Tracks nil. This screenshot from JEP-FD was taken during that same period of effectivity from the Shanwick track message, and as you can see, there are no westbound tracks displayed. So that kind of makes it easy for you to determine when the tracks are not in use. And this is a screenshot from ForeFlight during that same period of effectivity from the Shanwick track message. As you can see, the track is present on this display. Now we do want to be clear and point out that the time set on our iPad is set to Zulu time. So the problem that we're pointing out here is you see a track displayed during the current period of effectivity from the current track message from March 9. However, the track that is being displayed is from the previous day. This is from March 8. So be careful when you're using ForeFlight or JEP-FD to display the tracks, because they sometimes will show the track when the track is not effective. Our next North Atlantic update topic is the subject of the use of HF. There seems to be a perennial discussion regarding getting rid of HF radios and perhaps substituting SATCOM voice. And we've recently received some more questions concerning this. So we thought we would discuss this in our North Atlantic update. We'll start with a quick peek at the North Atlantic Operations Manual. Chapter 6 in NatDoc 007 addresses communications and position reporting procedures, and Section 6.1 addresses the equipment requirements, or as they state it, equipage requirements. 6.1.1 indicates, without question, that operations in the NAT outside of VHF coverage still require the carriage of two long-range communication systems, one of which must be HF. Section 4.2.12 reiterates this point that HF is mandatory. However, they do go on to point out in this section that if you don't have HF, then you need to plan your route according to the information in the AIPs and remain within VHF coverage. To approach this topic from a different angle, we're going to use the North Atlantic Implementation Management Group meeting notes from November of 2020. As you can see on page 6, regarding their decision of the utilization of SAT voice in the NAT region, the SAT voice project team determined that at this time, SAT voice has not been proven to be acceptable as a standalone backup for CPDLC due to infrastructure challenges and shortfalls, it states right there. So HF, therefore, is still a requirement in the NAT. We will wrap up our North Atlantic updates with a slight reprise of a subject we covered at last month's NBAA FOC, and this regards the misunderstanding of route clearance uplinks. For this topic, we refer to 3 NAT OPS Bulletins. The first one is the Waypoint Insertion Verification Special Emphasis Items. Another one is the NAT Datalink Special Emphasis Items. And finally, we look at the Oceanic Errors that was published in January. In fact, all 3 of these bulletins have been updated within the last 6 weeks, and they each address route clearance uplinks, or push-to-load flight plans. The NAT Datalink Special Emphasis Items Bulletin provides background information and guidance that operators could use in their pilot and dispatcher training programs. Section 4 points out that flight crews must be familiar with the proper loading and execution of these following route clearance uplinks. One is the Proceed Direct To uplink, and the second one is the Cleared To Via uplink. Now, this note points out the fact that experience shows that flight crews are often getting this wrong and they're misunderstanding the Cleared To Via message. They either put it in incorrectly and fly directly to the Cleared To, or they perceive the clearance as a Direct To. The first one, the Proceed Direct To message, instead of the Cleared To Via. When the route clearance is uplinked to you via CPDLC, that clearance will come to you in a full latitude-longitude format, and the navigation computer on board your aircraft will recognize that latitude-longitude format. However, what you see displayed on your FMS CDU will be the result of the CMU taking that information and displaying it on your CDU. So it's going to show up in that AirInc 424 format that we talked about earlier, and that very well may be unfamiliar to you. Hopefully by this point, you have perceived the importance of receiving proper training on these 5-character waypoint identifiers, in addition to the need to properly verify the waypoints when you do receive them. So to illustrate, this is a Cleared To Via route clearance uplink. You are cleared to Resno via a route clearance. Now you don't see that route clearance on this page. You'll have to tap that ATC clearance button to see the route clearance. But what we're trying to point out here is this is not direct to Resno. You're not cleared direct to Resno. You're cleared to Resno via a route. Now this, on the other hand, is a clearance direct to Resno, and you can clearly see it. It states, Proceed Direct to Resno. So there's the difference between the 2 messages. Now, as I pointed out earlier, on this route clearance uplink cleared to Resno via the route clearance, you don't actually see the route clearance. You have to touch ATC clearance in order to get to that page. And this is a critical step to complete before accepting this clearance. You need to review the route that was uploaded to you and verify the waypoints before you accept them and make them the active flight plan. As you see in this illustration, when a push-to-load flight plan is uplinked to you and it includes a full 13-character format waypoint, because that waypoint is undesignated, that 13-character gets replaced with this randomly generated code, in this case an asterisk LL03. Honeywell systems will use this random generation, the asterisk LL03, for example, while Collins will use just an extra numeral. They would have a code that would look like LL003. But they'll both represent a 13-character undesignated waypoint. The CMU cannot display that 13-character waypoint on your CDU, so it changes it to this randomly generated code. Now, of course, you're going to need to select the Flight Plan Review button in order to see the full 13-character digits and compare that to your flight plan before accepting it and activating it. For some of you, you might be feeling like we're kind of beating a dead horse here because you've heard this many times before. However, as recently as this January 29 publication of Oceanic Errors, the NAT SOG is pointing out that this continues to be a problem. And in this bulletin, they are pointing out that crews need to understand the proper responses for these CPDLC messages, as well as understanding the nature of the message in the first place. So when you receive a cleared to via route clearance, a route clearance uplink, or what we call a push to load, you need to know how to respond to those properly as well. So it's vital that you understand the menu hierarchy and how to load the CPDLC clearances and the responses. And of course, if you're unfamiliar with that, you can always contact us and we'll be glad to help you learn this information. Now, this concludes our 30 West IP update for March of 2021. We hope we were able to clear up some questions you may have had on these topics. And if not, you're more than welcome to contact us, and we'll try to help answer your questions. Thank you.